Today we're going to look at this exercise that we did in class. We were given the function f of x is equals to 0 for x less than -1, and 1 plus x for x belonging to -1 and with 0 not inclusive, and 1 minus x for x belonging to 0 with 1 not inclusive, and 0 for x greater than 1. So we've been asked to calculate the probability that f is between -1 half and then half. And then we've also been asked to calculate the distribution. So let's start by looking at the first case, the probability that, so first we are looking at the probability that x belongs to -half and then half. X belonging to -half and half. So let's look at the question again. Now, when you look at the question, f of x between -half means it's going to fall within these two functions, because -half, this is -1 up to 0. So -half will be in the second function here, right? And then half, the upper limit half also will be in this function, because 0 and 1 is in between this that you can have half, right? So that means the problem that we have been asked to find resides in these two functions, right? So what it means is that I will have to decompose this probability in order to do that, right? So I can say, because I know that the -half, so I can say, okay, -half to half is the same as probability of -half up to 0, right? Plus 0 up to half. In this case, once I've been able to decompose this one into this, that means I can first solve for this using the second expression here, right? But that means I'll have -half to 0 to fall within that range. And then I can also solve for this expression here using this third expression, right? Then when you add up this, it gives you this one, right? Great. So that means I can say that then the probability of x, probability that x belongs to -half and then half is the same as I integrate from -half to 0, -half to 0, and that function, the second function, was 1 plus x dx, plus I integrate from 0 up to half, and that expression is also 1 minus x dx is okay. So when I integrate this expression here, I'm going to have x plus s squared all over 2 into bracket. Then I start from 0 up to half, plus when I integrate this 2, I'm also going to have x minus s squared all over 2. And that also starts from what? 0 up to half, right? Yeah. So this expression is going to give me 0 minus because when I fix 0, everything is going to be 0, right? Minus -half plus -half squared all over 2 plus so that is for the first expression here. This is for the first expression here, and this expression is also going to give me half minus half squared all over 2 minus 0 is okay. Yeah, so when you finalize everything, you are going to have 6 over 8, which is the same as 3 over 4. That's when you simplify whatever I have there, right? So the second part is to calculate the distribution. That is f of t, which is always the same as what? F of t, which is the same as integral of -infinity to t f of x dx, right? Now, so for this one, we are going to say that, okay, f of xt is equals to 0 for t less than -1 is okay. Because when you look at the question, here we said it's 0 when t is less than -1, right? So that's what I've stated. Great. Now the next one is 4x. Okay, so let me come to this place. So we come to the second one for x belonging to -1 with 0 not inclusive. So that means I'm going to integrate from -1 up to t, and then the f of x now becomes, because from that way f of x becomes 1 plus x dx, right? That will give you x plus s squared all over 2, and then you have it as t minus 1. Now when you expand it, you are going to have it as t plus t squared over 2 plus half, or let me write it here. I'm going to have it as t plus t squared over 2 plus half is okay. Now the next one becomes for x belonging to 0 but 1 not inclusive. That is also going to give integral from 0 to t 1 minus x, because this range has this function here, 1 minus x dx. So when I integrate, I'm going to have x minus s squared all over 2 from 0 up to t. And that also gives you t minus t squared over 2 is okay. And for x, the last one is for t greater than 1, right? That means you integrate from -1 to 1 f of x dx. Because, but when you integrate any function from the upper limit, from the lower limit to the upper limit, it always gives you 1, right? So then I can say then the distribution function is equals to 0 for t less than -1, and then t squared plus t squared all over 2 plus half for t belonging to -1, 0 not inclusive. And the next one becomes t squared, sorry, it becomes t minus, not t squared, it becomes t minus t squared on 2 for t for belonging to 0 and then 1 not inclusive is okay, and then 1 for t greater than 1. So this becomes what the distribution is okay. So when you're asked to calculate the distribution, this is how you do it. And thank you. So in our next video, I'm going to look at the expectations. Bye.